Let's look at part 2. By further differentiation, use of the result in part 1. Find the series up to including x squared, meaning we need to find all the way to d squared y dx squared. Okay, so means we just differentiate once more. So this part 2 here. Differentiate 1 with respect to x. This will be, keep the one on the right, dy, d squared y dx squared, plus dy dx. Keep the one on the right, differentiate the one on the left will be 2 dy dx. Okay, so keep the one left, differentiate right, keep then 2y dy dx minus ex cosine x plus sine x ex. Alright, so I think this is pretty okay. uv prime plus v u prime. Then this case here on the one on the right, u and v uv prime plus vu prime. Okay, that's about it. What we're going to do next is essentially, you don't need to simplify them because what we need is just to hunt for all the different terms, right? So when x is 0, what we have is y is equals to cosine 0 is 1, e0 is 1, so y is 1. Okay, then we need to find dy dx here, so just key this in. Y is 1, so when you find your y is 1, so this case is 2 1 dy dx is what we need to find. Y is 1, 0 sine 0 is 0, so dy dx is just half. Okay, so that's how we do it. This is dy dx equals to half. So this one don't really need to same thing, don't need to simplify because we just need to find what are the values there. So y is 1, so this would just be 2 times 1 d squared y dx squared. I like to find the one dy dx would just be half times 2 times half equals to 2y times half minus 2y, which is 1, right, times half. E0 is 1, cosine 1 is 1, sine 0 is 0, so this will be 0 here. Okay, so this part will be 0, then this will be d squared y dx squared would just be, this is 0 minus half, negative 1/4. So this case here, what I'll get is actually d squared y dx squared is actually just minus 1/4. Okay, so this case here, y, the Maclaurin series of y will be, just bring out Maclaurin series here.